Now we're done with DC circuits, and it's time to start looking at magnetic fields. The first introduction that we have to magnets is typically with something like fridge magnets or things that stick together, essentially have permanent magnets. And it turns out that permanent magnets are much more complicated to talk about, and it's not covered in detail in an introductory physics course. So I'm going to focus on what's going to help you get the better grades, and which actually has more to do with the magnetic force on an electric charge. So when talking about magnetic fields, first I'll just really quickly show you magnetic field lines. They go from north to south, but it's a very similar concept to electric fields. Then we're going to look at the magnetic force on an electric charge, and more specifically on the motion of a charged particle that's moving in a magnetic field. And then we extend that to the magnetic force on a current carrying wire, because a wire that's carrying current is carrying moving charges. So this applies directly, and basically we come up with a simplifying equation for that. Then the last thing that I'm going to look at here in this chapter is the torque on a current loop, where I look at a loop of current. So we have wires bent into a loop, and then you have a current flowing through it. And just from the nature of that setup, when you put that loop in a magnetic field and you have current flowing through, it actually feels a torque and it wants to turn. The torque causes it to turn, which is exactly how an electric motor is created.